Hi everyone, so this week I had the fun of going to talk to some sixth form college students and I spoke to them a little bit about quantum computing, this weird algorithm called the RSA algorithm, and how a quantum computer might affect us going forward. So today, for today's vlog, I thought I would do a little bit about quantum computing. So yeah, welcome to my channel, I'm Caroline, and let's get on with it. So a typical computer uses something called a bit, and that is a series of essentially ones and zeros. So something is either on or off. And that's the computing system that we all use today. Now what is exciting is that might be, well it is, about to change. Quantum computing completely changes this whole idea. It uses something called a qubit, and that goes into the weird and wonderful world of quantum physics. So a classic example is think of an electron. Now an electron has a spin up, so half a spin up, and it has a spin down, half a spin down. Spin is a weird property which is intrinsic to the particle. So it's not anything we can kind of describe in a classical world. It's like having mass, the particle just has spin. Now what is weird is we can do experiments and we can see the electrons being spin up or spin down. But if we were to isolate an electron and just to leave it alone, then in the weird world of quantum mechanics, it obeys superposition. So that means simultaneously it could both be spin up and spin down. Now, that's a bit weird, but it's this idea of superposition that a quantum computer taps into. Rather than having a discrete 1 or 0, on or off, the quantum computer uses a qubit. And that means something can hold multiple states, allowing us to do calculations much, much faster. Think of it, rather than just going down a track, reaching a dead end, turning around, come back again, go down a different track, reach a dead end, turn around, come back again, a new quantum computer would allow us to go down all the tracks simultaneously and work out the best one. It could revolutionise the way we do computing of large algorithms. If we've got a problem with many variables and complicated bits of equations we need to manipulate, a quantum computer, thanks to this weird superposition of states being able to be both up and down at the same time, means we can hold so much more information, we can process the calculation much faster. This is really exciting if you're trying to process a calculation that requires you to do a lot of computing. So if we were looking, say, at a system that has many variables, so we wanted to look at a chemical compound or a chemical formula and explore the chemical composition of two things as they interacted, now there could be potentially loads of outcomes, but we could use maybe a quantum computer to explore all of these combinations and possibilities so much faster than our current computers. But of course, with new advances, there always comes a bit of a problem. Now, some people want to use technology for good, and some people maybe not quite so much. And there is a worry that if we have these wonderful new quantum computers, they might start to undo all of our computer security. Now, there's quite a famous algorithm. It's got a catchy title, as all algorithms do, the RSA algorithm. Hang on a second, I can tell you why it's called the RSA algorithm. It's named after the three people who came up with it. Hope you'll get their name pronunciation correct. Ribest, Shamir and Alderman. But anyway, these three gentlemen came up with the idea of using the RSA algorithm to help protect our data. It's, to put it mildly, a little bit complicated. But the general gist is that you start with two numbers. Let's say you start with two prime numbers, P and Q, and you multiply those prime numbers together to give you the number n. Now, in the world of the RSA algorithm, n becomes the modulus for both the public and the private key. Still with me? Okay. Next bit is you have to calculate something called the totient. So you do your first prime number minus 1 multiplied by your second prime number minus 1, and that gives you another value. And now you're looking for numbers that are co-prime between this new value that you've just calculated and your first value, n. And by co-prime, we're looking for them to share factors of just 1. You're still getting with me? So this whole bit of your P's and Q's to make an N and then working out the totient is to get you your public key. So your public key comprises of N and this number, this coprime number between the two variables. And so your public key is the thing that you share publicly to help encode your secret message or your data. Now, to read it or decode it, we need to have a private exponent. We need to have a private key that only the person who's meant to read the message understands. And so you have to calculate a private exponent. The mathematics is quite tricky to do this, but then your private key becomes your original prime number P, your second prime number Q, and this private exponent that you create. Essentially, there's a lot of complex mathematics, but if you were to look from the top down, basically you're using numbers that are very large and very complicated and very difficult to be able to work out the factors that make up a number. And that is what the code relies on. It relies on the fact that the number is so big, it becomes incredibly difficult for our standard computers to be able to work it out without knowing the private key. And that works really well right now when we have a computer that only deals in bits, ones and zeros. Potentially, it could go a little bit wrong if we have a quantum computer. Now, Google have already announced that they're doing calculations potentially that are, thousands of times quicker than a conventional computer. Because what a quantum computer allows us to do, potentially, is to do simultaneous calculations really, really fast. And if we can do that, the long number that we were using to help protect our information with the secret key, we might be able to crack that within a matter of minutes. And so quantum computing could be an amazing tool that allows us to perform calculations so much faster than ever before. But quantum computing might also be the reason we need to change all of our security protocols in the future. It's very complicated. I don't think I explained it very well in a very short period of time. So I will pop a couple of links below if you're interested in quantum computing or the RSA algorithm or the future of all things quantum. I'm going to go back to using my regular computer, so my normal ones and zeros. I'm currently working on an algorithm to do with fuzzy logic. Maybe next week I'll share a little bit about how fuzzy logic works. But in the meantime, I hope you have a wonderful week, a great weekend, and I'll see you next Thursday back here on Charming Quarks for more physics lecture lifestyle. All right, bye.